Okay, here we go. So we're going to talk about how we find horizontal and vertical tangents because we have not done any calculus on a polar yet. Okay? So you need to write down those things right now on your paper. Okay? Or in your notes.
Polar graphs and polar coordinates are 2. Polar coordinates, polar graphs? 2. Like 140. Rope?
Okay, turn the music off, please. Let's get this written down.
I don't wanna. Can we just take a day off, dude?
You can put your head down anytime you want, but don't expect me to not have this on the test. Okay, so if f is a differentiable function, then it gives us the slope, okay? Really what that is a slope, and we don't actually ever use, in your book actually gives you that slope and then does no problems on it. I don't understand that, but that's what the way it is. We tend to use polar when we're talking about polar. We tend to they want it on the AP test, they want us to integrate it, okay? So I'm not going to worry about you writing that down, and at least we have the formula if we ever run across a problem on it. It's basically the product rule, okay? It's kind of using the product rule there. And then the horizontal tangents come from dy d theta equaling 0. And then the vertical tangents come from dx d theta equaling 0. Okay? The problem is that whatever equation they give us, you have to get it into polar form first before we can take its derivative. Okay? So that's a little bit of a change. That's why we have the slope the way it is. All right. Why does it look like it's dying? It is?
Unless it always makes that noise.
Oh, no, it makes that noise. It usually makes that noise. Alright. I hope it's not dying. Alright. There you go.
Is this pretty easy too?
There's only 2 problems. It's not, I don't think that it's difficult. I think it's tedious.
Are they just long?
Yeah, that's what I meant by tedious. Yes, they're long. Okay. Alright.
Tedious.
Tedious work.
Alright, everybody got what they need there? Yeah. Okay. So I believe the example that they give you is r equals sine theta. Is that right?
Yes.
Okay. So in order to find we have to actually put that into x equals and y equals to do dy d theta or dx d theta and dy d theta. So remember you have the polar equation r equals cosine theta and r equals sine theta. So you have to substitute your function into that before we can take the derivative. Okay? So I'm going to get that x equals sine theta times cosine theta, and y equals sine theta times sine theta, which is really sine squared theta or sine theta squared. Okay? I am going to start by finding my vertical tangents. So I'm going to take 2 screens to do this. Okay? And my vertical tangents are, remember, dx d theta. So, we know how to do this, okay? Again, it's the final part of the answer that's tedious. Okay? It's the trig piece that's a little bit difficult. All right, so we've got a good old product rule. So product rule says we keep the first. So what's the first? Sine theta, good. And the derivative of the second is what? Negative sine theta for the derivative. Okay, so keep the first, derivative of the second. Then we keep the second, which is cosine theta. What's the derivative of the first? Cosine theta. Okay. All right. Do I have up there on Haiku, like on the welcome page? Do I have a trig table? Check it out and see if I have one, because we're going to need it here. Okay. Do I have one there? Okay, everybody get it in front of you. Okay. All right. So, what is cosine squared times cosine squared? Or sorry, cosine times cosine is? Cosine squared, and sine times sine is? Sine squared. Okay, so what I want you to do is I want you to look through your trig table and see if you can find something that we can convert that into. So what's cosine squared minus sine squared? We all looking through the trig table? I'm thinking double angle. Is it on your double angle? There you go. It's the same as cosine 2 theta. Okay? So now that I have an equation, in order to get a vertical tangent, what are we supposed to set the derivative equal to? To 0. So I'm going to set it equal to 0. So on my unit circle, and you happen to have a unit circle there in front of you if you've got the trig table up, if you don't remember it, where is the cosine, the x value, equal to 0?
0.
It's not at 0.
1 pi.
Pi over 2. Where else?
That
3 pi over 2. Good. Okay, so I'm going to get this 2 to the other side. How do we get that 2 to the other side?
You multiply it.
You multiply by 1/2. Okay, so we've got that theta equals pi over 4, and theta equals 3 pi over 4. Okay, here's the downside. Those are the theta values. What they wanted me to find was a point. Okay, so I have to go ahead and I have to plug that back into my original equation to get the r value. Okay, so I have r equals sine of pi over 4, and r equals sine of 3 pi over 4. This is just the first half of the problem. Okay? R equals, what's sine of pi over 4? Square root of 2 over 2. Good. All right, and then what is sine of 3 pi over 4? It's also square root of 2 over 2.
Right.
Because 3 pi over 4 is in quadrant 2, right? So then the actual points of vertical tangency would be square root of 2 over 2, pi over 4, and then square root of 2 over 2, 3 pi over 4. Okay?
We're done?
No.
Oh.
That's just the first half of the problem. We still have to, we found the vertical tangents. Okay? We now need to find the horizontal tangents. Okay? This one won't. Okay? So now I'm going to take the derivative of this one here. Okay? So I'm going to go to my second page. So it's really, we're taking the derivative of sine theta squared. Okay? I know. Alright, so this is horizontal. Alright, so dy d theta equals, what's going to happen with that 2? It's going to go to the front, right? So 2 sine theta. And then what's the derivative of the inside? Cosine theta, right? Alright, I want you to go look at your double angles again. And give me something that converts into. Okay, so sine, this is the same as saying sine 2 theta. I'm sure your coach would love it that you're not working.
Oh, why would you?
He told me on Friday to tell me when you're not working.
He didn't say that.
He did. I talked to him, actually.
Why would you talk to my coach?
Because I told him you were doing a good job, and now I'm lying because you're not doing your work. All right. Okay. So, we're going to find where the sine is equal to 0. So where is the sine equal to 0 now?
0 and pi.
There you go. 0 and pi.
You tell my coach who said that.
2 pi also, but 0, it's the same as 0, right? So we only need to go where it's the same, where one time on each one. All right, what am I going to do to move the 2 to the other side? Divide. So you got 0 and pi over 2. Okay. So now to find the points of horizontal tangency, I have to plug back into my original, which was r equals sine theta. Okay. So r equals sine of 0. What happened?
Non-jump quit.
Oh, I know what happened.
It's a 4.
Kaylee was right, I was wrong. Okay. It should have been 2 pi, not 0. Let's err on the side of 2 pi. So when I divide, I get pi. Okay? So I'm going to put in the sine of pi. What is the sine of pi?
1.
Isn't it? Oh, sorry. The sine of pi is 0, right? Okay. I guess it wouldn't have mattered on that one. So it would be, so I have the value 0 pi as one of my points. And then r equals the sine of pi over 2. What's the sine of pi over 2? 1. So my other point is 1 pi over 2. Okay. On the next one, I'm going to change it a little bit from what's there. Okay? After the next one, yes. Okay. On this one, we're done now. Yes. Okay? All right. So I'm going to change the problem a little bit, okay, to make it a little bit more reasonable. You have a 2 in front. I'm just going to take it down to 1 minus cosine theta. Yep, cross out the 2. And then in the instructions, let's just try to find the vertical tangents. Okay? So I'm just going to go for the points of vertical tangency. When I changed the problem, I was having trouble getting the horizontals, so I don't want to mess you guys up by not being able to do it for you. So, okay. So, to get the vertical tangents, remember I have to put it into this x equals r cosine theta, right? I'm sorry, it's not x, it's supposed to be y, isn't it?
No, it's X.
It's x? Huh? Vertical is x? Okay. Alright, so we're going to go ahead and plug this in for the r. So x equals 1 minus cosine theta times cosine theta. Okay?
Oh, so the r is the whole equation, 1 minus...
Yes.
Oh, okay.
And then this is what you have on your paper, right? And then we have to plug into our polar, okay, equation and get it in terms of x before I take a derivative. Alright, what do you think you would do from here?
Derivative.
I could derivative there, but I'd have a product rule. Could I distribute this first?
No.
Sure, why not? So x equals cosine theta minus cosine squared theta. Alright. Now let's go ahead and... What did we do there? Let's go ahead and take our derivative, okay? So dx d theta. So what is the derivative of cosine? Negative sine theta. Okay? This one here, remember you got to think of it like cosine theta squared. So where's the 2 going to go?
In front.
In front. So minus 2 cosine theta. And then what's the derivative of the cosine?
Sine.
Sine theta. Alright, before I try to get this equal to 0, I am going to factor out a negative sign. So I've got negative sign being factored out, which is going to leave me with 1 plus...
2 cosine.
2, I did something wrong here. What the derivative of cosine is negative sine, isn't it? So isn't that going to flip that positive? Which is going to make this negative. Okay, so 1 minus 2 cosine theta. Now we're going to set that equal to 0 to get our points of vertical tangency. So, remember 0 product property says I split those both up and set them equal to 0. Minus 2 cosine theta equals 0.
Are we finding the little Uzi Vert?
What?
I was just asking for finding the vertical.
Yeah, we're just going to find the vertical tangent. Alright, so what 2 places does sine of theta equal 0? 2 pi and pi. Okay, let's go with 2 pi and with pi. Okay. And then over here off of this one, I've got that we've negative 2 cosine theta equals negative 1 and cosine theta equals 1/2. So where does cosine equal positive 1/2? What 2 places?
5 over 2?
Not pi over 2.
Pi.
No. We sure? Pi over 3. Okay, where else?
3, 2 pi over 6.
5 pi over 3. Yes, Joaquin?
Where'd you get 2 pi and pi? Like, why'd you put that there?
Why'd I put this here? Because we have to solve for theta, the angle. So this is where we reverse our unit circle. So you look for this x coordinate on the unit circle. Oh, sorry, y coordinate on the unit circle. And then you read the angle measure off. Okay? All right. So I have the thetas. I still need to calculate the r's, right? So we're going to go back into this guy right here and calculate my 4 r values. So there's actually 4 of them this time instead of just 2. Okay?
We're gonna come up with 4 different coordinates? Or?
It depends on the problem. Like the last one, it only had 2, right? This one, and this is just for the vertical.
So how many thetas we have is how many coordinates will in the pattern?
Yeah. Okay. All right. So we've got r equals 1 minus cosine of 2 pi. What's the cosine of 2 pi? It's 1, right? So 1 minus 1 is going to be what? 0. I'm going to list my coordinates up here. So I know I've got the coordinate 0, 2 pi, or 0, 0. All right, r equals 1 minus cosine of pi. What's the cosine of pi? It's negative 1, isn't it? So that's going to be 2. So 2 pi is going to be a coordinate. All right, I'm going to have to draw my work up here a little bit. Okay? R equals 1 minus cosine of pi over 3. What's the cosine of pi over 3? 1/2. So we just get 1/2 on that one. So this one is 1/2 pi over 3. And then r equals 1 minus the cosine of 5 pi over 3. What's the cosine of 5 pi over 3? Also 1/2. So this one comes out to be 1/2. 5 pi over 3. Okay? I assigned 3 homework problems. Okay?
What?
Alright, so I'm going to give you guys the rest of the period to work on the 3 homework problems. Okay? There's only 3. Alright, I'm going to try to figure out how to do the horizontal on this one while you're doing the 3. Okay, if you want something stamped, now's your opportunity. Okay. Okay. So, let's go for our horizontal tangents. So we're going to look for the horizontals this time. Remember, we're looking for y equals r sine theta, and the r we had was 1 minus cosine theta, right? Okay, I'm going to take the derivative, but instead of distributing this time, I'm going to go ahead and do the product rule, because that's another way I could do it. I want to make sure you've seen both. Okay, so dy d theta equals, keep the first, right? So 1 minus cosine theta. What's the derivative of the second? Cosine theta. Plus, I keep the second, sine theta. What's the derivative of the first? It's going to be sine theta, right? Because the derivative of negative cosine, it would be negative sine, right? So it goes positive. All right. I am going to go ahead and try to distribute this in now. So I've got cosine theta minus cosine squared theta plus sine squared theta. Alright, it would be really handy if it was in all cosines or all sines. So I'm going to use trig now. Okay? I want you to look at your Pythagorean identities. What can I replace sine squared with? 1 minus cosine squared theta. Good. This comes up in the homework, so I want to make sure you're prepared for it. Okay? Alright, so let's do some combining of some like terms here before I set it equal to 0. I got negative cosine squared and negative cosine squared. What's that? Negative 2 cosine squared plus cosine theta plus 1. And we're supposed to take the derivative, set it equal to 0 to get our points of horizontal tangency. I don't like that leading coefficient, so I'm going to divide everything by -1, which means what am I going to do to all the signs? We're going to change them all. Okay, so minus cosine theta minus 1 equals 0. Okay. I want you, and this is a review of trig, I want you to take this and I want you to think of it as 2x squared minus x minus 1. Couldn't we factor that? Couldn't you do your good old magic x in a box if you were in my class, right? Or whatever Miss Dudley did or Miss Rondeau did. I don't know who you had at that point. Okay? So I want everybody to factor that and tell me what your factors would be in x. Okay, so take a minute, factor it. To yourself, everybody factor it. Really disappointing me because you guys had me. Two numbers that multiply to the top and add to the bottom, right? Yeah.
Mm-hmm. I knew the x, it's the box, I don't know.
So what times what is 2? 2 and 1, right? How many times does 2 divide -x? Remember that? If you weren't in my class, you didn't do it that way. My class did it that way.
Can you show us the box?
I just did show you the box.
I was trying to write it and wasn't working.
So, what two numbers multiply to 2x squared? 2 and x, right? How many times does 2x divide -2x? -1 times, right? It pops out there like a multiplication table. How many times does x divide 1x? And then you check it 1 times -1 is. I like it that one because it has a check in it. Okay? Alright. Instead of writing the x's in there, what am I going to write in instead of x? Cosine. Okay. We did do this when we did trig. 2 cosine theta plus 1 times cosine theta minus 1 equals 0. At this point, we're back to zero product property and solving for the theta. So if I'm going to take both of these guys and set them equal to 0, and you guys, there are steps here you could probably cut out. Some of you could probably just solve it in your head at this point. So if I were to take this thing here and solve it, wouldn't it be equal to -1/2? Because I subtract the 1 and divide by 2. This one here would be equal to 1. So at least we eliminated a line of work there. Alright, so now we're back to unit circle. And on unit circle, where does cosine equal -1/2? Okay, 2 pi over 3 and 4 pi over 3 is what I'm hearing. What about where does cosine equal 1? 0, right?
0.
At pi, it's -1, isn't it? Okay, so let's find our points of horizontal tangency. I have to plug into r equals 1 minus cosine theta. Okay, and I'm plugging these three things in. So, r equals 1 minus cosine of 2 pi over 3. What's the cosine of 2 pi over 3? Isn't it -1/2? So that's going to be 3/2, isn't it? So I have the point 3/2 2 pi over 3. Alright, then we've got r equals 1 minus cosine of 4 pi over 3. What's the cosine of 4 pi over 3? Also -1/2, right? So don't I get 3/2? So 3/2 4 pi over 3. Then I also have to put in r equals 1 minus cosine of 0. What's the cosine of 0? 1, right? So it's 0, so I get the point 0, 0. Okay, once you have that done, because that's it for the notes, but I want to show you on the picture so you can kind of visualize what we just did with what it is. Okay? I want you to graph So go into Desmos and graph this. Or on your calculator if you want to. I'm gonna try to go to Desmos and graph it once you guys have it all written down. Okay. Are we all written? Not yet? Almost. Okay, I'm gonna go to Desmos 2 and graph it. Can't get it in there right. Make sure you do r equals, right? 1 minus cosine theta. And then I want to put it onto the polar one. So to do it onto the polar, you change your settings over here to the polar grid. Alright, I'm going to zoom a little bit. Okay. Looking at what I've got there, so we just did horizontal and vertical tangents, right? So if I think about my vertical tangents, it said there was one at 1/2 pi over 3. So if I look at this pi over 3, isn't there a vertical tangent about right there if I were to draw it? Right? And same thing right here. That would be the 1/2 and 5 pi over 3. Okay? There's definitely one I could draw at 0, 0, right? It's actually touching it. Oops. And then I could draw another one. It was out to and over and on the pi radian measure, right? Then if I went and I looked at my horizontal tangents, I'm not so sure I would agree with 0, 0, but I guess you could draw one through there. But definitely 2 pi over 3. If I look at 2 pi over 3, couldn't I draw a horizontal line and it would touch it right there? And then also at 4 pi over 3. So at 4 pi over 3 right there on that radian measure. So I knew when I was doing the problem I wasn't getting 3 when I looked at the picture, horizontals. I knew I was doing something wrong. So you can, if you have to, you can always go back to your picture and make sure you're at least getting the right number. So you can kind of visualize where they should be. Okay? Alright, that's where I'm going to stop. You have lots of time to get the 3 homework problems done. I only gave you 3 because I know this isn't short. Okay. If you want something stamped, I'm more than happy to stamp it. So you can bring it back here and I will stamp. Okay.